Okay. I have started the recording. Welcome everyone for the Python workshop, Tkinter. Was anyone here for our Friday workshop? Show of hands. Okay, good. New faces. I like to see that. I just want to start off with saying that the benefit that you guys get by trekking through this awful rain and being here and not watching a YouTube video is engagement, right? So at any point, if you have a question, stop me. That's what you're here for, right? And you've heard the spiel. Maybe someone else has that problem, whatever. Just ask. It's fine, right? We're not gonna go super quick. I'm just trying to get you guys, introduced to the topic, to Tkinter and whatnot. So I'm just gonna go ahead and get started. I made a little PowerPoint here. Just make sure. I'm gonna get rid of this weird OK symbol at the top. Hold on. There you go. Awesome. So yeah, first things first, you are gonna need Python. Does anyone not have Python installed? Perfect. So for most people, Tkinter is actually going to be bundled in with Python. The only exceptions is Linux. Anyone else in here on Linux? So you're just going to run apt install. Okay, perfect. Yep, you know how it goes. All right, so what is Tkinter? We're going to start that first fundamentally. Tkinter is something called a GUI kind of framework or library. You might have heard GUI before from video games or maybe some type of program in the past. Really, all that is it's a way to make something you can see, hence a graphical user interface, right? Another thing that's really, really important about a GUI is the I part. That means interface. That means you are going to be interacting with this. So you're going to also have to consider not only how are we displaying the things that we're making code for, but also how are we taking in those inputs, right? Things like clicking, things like typing, things like dragging the window. Are all things that GUI frameworks are concerned with, and that's what Tkinter is going to help you do. And so there's a lot of really, really, really complicated things you can do with GUI frameworks. Like, for example, when you press Control, Shift, and then F on File Manager, it'll change its name or something. There's lots of very complex bindings you can make with GUI libraries, but we're really only going to be covering the basics for now. And then obviously on your own, feel free to explore, go through whatever. And I will point you all to the documentation, and I'll make sure to put it in chat at the end. It's pretty good docs, actually, considering how dirt old Tkinter is. Has anyone ever looked at Tkinter before, ever? Okay, awesome. So I want to get this out of the way now because there will be questions about it. While I'm writing code, there will be two things that I use, TK and TTK. So what's the difference? They sound very similar. Well, that's because they are quite literally the same thing. It was just TTK is basically TK2. It was so futurized and advanced, and it makes things a whole lot easier. The interfaces are a lot nicer. It looks a lot better on screen. So for certain components, we will be using TTK. Other than that, conceptually, it is literally the same framework. It does not make a difference. Don't feel overwhelmed. And everything that is in TTK, you can use in TK. So if you accidentally use a TK button instead of a TTK button, it is not going to blow up your app. It's fine. It's just how you interact with it. Things like changing its text, getting its color. All of those things might change, but at the end of the day, TTK is usually better. Most of the time, if there is a TTK version, I will use that instead. But again, both of these should be pre-bundled and pre-installed in your Python versions. So wanted to get that out of the way now because it can 100% get confusing at first. So when it comes to Tkinter specifically, there's a lot of these type of concepts that show up in other GUI libraries, but the three biggest things of a Tkinter app is going to be the structure here. It's going to be widgets. Those are going to be the actual components that you're putting on the screen. So things like text input, labels, buttons, radio checkboxes, drop downs, anything that's like think of it like a Lego piece, right? You're putting this all over your screen in a programmatic way. Styles. You style them because you'll see I didn't spend much time styling for this demo, and Tkinter looks very archaic. Is that a question or? Yeah. All right, you're good. And then the last thing is going to be layout, right? So if anyone's been exposed to CSS or web development or anything like that, there's things like Flex, right? There's things like grid. How are we actually putting our widgets, styled or unstyled, doesn't matter. How are we putting them on the screen, right? So that's another thing that we're concerned with, and there's a ton of different layouts. Actually, that's a big lie. There's three. There's pack, grid, and place. I'll be going over pack, and I'll be going over grid. Place is a little weird, but I will mention it eventually. And then as for styles, it's pretty similar to CSS. Things like padding, right? How much distance do we want between all of our elements? What color do we want them? Do we want it bold? Anything like that. is going to be concerned with styles. So here's something that's going to be a little new for some people, especially if you haven't really done stuff out of class, because honestly, I don't think class touches event-driven programming until like your junior year, which is pretty crazy. Something that we need to distinguish, right? A lot of the time, you're going to be writing like sequential code. And what do I mean by that? I mean, it goes from the top line and it goes to the bottom. There may be some loops that spin it around and throw it over here and bring it back over here, but it's going down. And eventually you hit that last line of code and your thing exits. And right, there's some, edge cases with like, oh, what if I hit an error and I cut the program? That's fine too. But the point of it is that it's sequential. You can almost trace the exact path that your code's going to take based on your input. It's entirely deterministic, right? So event-driven programming is a little different. Websites are event-driven, right? What we're going to make is event-driven. And by that, I mean, imagine a program where it displayed a button and then you clicked it and it shuts off. And it's the end of the program. I click my button and the whole thing dies, right? We don't want that. For an actual website or a graphical user interface, it is going to last infinitely until you close it. And while it's up, it's going to be listening for events. And so things could be clicking, right? That's a pretty easy to follow event. When I click the button, I want it to do something, not show the button and do the thing top to bottom. It keeps looping infinitely. Things like games typically do this. Websites, these are all event driven. So that's something that you do need to consider when it comes from coming from class and start working on these projects, is that event driven programming is going to be a little different, right? Conceptually speaking. And so I'm going to go over a very, very simple hello world in Tkinter, super quick. Don't write this code. We're going to do it again together. I'm just trying to show you conceptually. So don't go jumping at your VS Code or whatever, right? So basically, the first thing that we're always going to do at the top of every Tic-Tac-Toe project is we are going to create a window object. That is this right here. Wait, I think I have here, I'll do it on this one. I thought I had like a PowerPoint thing. Okay, so the window right here, right? That is going to create an instance of your window. And it's literally just that, the window, right? So for example, this is my window, right? Oh, that frame rate is terrible. But that's my window, right? That's kind of like where everything's contained. That's kind of going to be like the most upper component that you have is the window. So we create a new window object. And from there, we can modify it a little bit. So we can change the title. You don't really see it on my screen because I've got my weird Linux setup. But sometimes at the top where it'll say Google Chrome at the top of the bar, you can set the title. You can set the geometry. If you don't want it to be fluid, you can set it to be 400 by 400. You can set it to be 100 by 200, just properties like that. But notice at the very, very bottom, and this might cause you some headache at first, you have to run the event loop. If you write all of this Tkinter code and do not start the event loop, it is not going to open. And you're going to sit there bashing your head into a wall. Why isn't it working? It's because you didn't actually start the loop. So at the very, very bottom, you see window.main. Oh, this is touchscreen. Whoops. Window.main loop, right? That's what's going to start that event. From there, we're going to talk a little bit about widgets, right? So widgets are, again, our building blocks. And so one of those is a label. A label doesn't really do much, at least it's not intended to. You can add behaviors if you click it and whatnot, but really what a label is supposed to be is text, right? Makes sense. So we're going to create a label and we're going to place that on the screen and have the text say hello world, right? So if we go here, this is the piece of code to create the label. You're going to notice a very similar pattern here as we do this workshop, that every single widget sort of takes the same beginning, right? You first create the label itself. This is holding on to the reference to the label. Imagine like it's a struct and it's holding all of that information. So with this variable right here, you can grab the text, you can grab, its position, all of those type of things, but the declaration is the important part. Notice how I'm using TTK, again, just a superset of TK, don't worry about it. Label, and these are case sensitive. You do need a capital L, not a lowercase l. But what the first parameter is always going to be in every Tkinter widget is going to be its parent, right? So that we're trying to think, what are we putting this thing on, right? We're creating a label, but where is it going, right? For most things, that's going to be the window because you're not going to place it outside of the window. But we can get complex. Maybe we want like a group of labels. We can put those labels, packing it on something else instead of the window, right? But anyways, the first input is always going to be the thing that you're putting that widget onto. And you'll see examples of frames later on. And then everything after that is actually optional. There are a ton of different parameters that you can put in. You can put in text, you can put in style, you can put in colors, you can put in behaviors, and you all specify them with this, right? So for example, text equals hello world. That one, again, kind of seems like common sense, and you'll kind of get used to the text is the easiest one to use. From there, we're going to use one of our three layout managers, right? Remember how I said there's grid, there's pack, and there's place. What pack is going to do is it's going to put it on the frame, the parent. So in this case, the window, one item on top of the other, like it's more like a queue than a stack. But so like you put a label on the window, it goes at the top. And if you made another label and packed it, it would go underneath it, so on and so forth. You can also do pack left and pack right, something else that you can do, which we'll see later on. But once you call that on there, it is now attached to the screen. And then from there, right, we've created our window, set our stuff there. We've created our hello world label, and we packed it. And that's what it's going to look like. There you go. We've got our little hello world, right? And that's it. But now the crazy part is that this isn't in the command line. This is a real app, if you could call it that. But it's real, right? You can run it. You can move it around. You can highlight the text. You can do whatever you want, right? And so that's it. That is the hello world. I'm going to dive into two simpler examples just to kind of get a feel, follow along. But then we're going to make something a little fun. We're going to make, well, here, let me show the docs. And I am actually going to, can zoom in. That's crazy. Okay. This looks bad, and it kind of is. But this is what has all of the documentation for Tkinter, right? So for example, we went to label options, right? There you go. So label has text variable, underline, image, compound, width. And you can go here and you can find out everything that all of these widgets take. Very, very helpful. I would 100% recommend looking through these docs if you're working on a project with this afterwards. And it's really, really good practice to get used to going through docs, because there's going to be a point in time where your only saving grace are these docs and not a YouTube video because you're doing something no one's done before, right? So get used to going through docs. That being said, this is what we're going to work up to, right? I was thinking, what is a staple project, right? We've got to-do lists. We've got, recipe trackers. We've got all those normal ones. And Tic-Tac-Toe, I was like, okay, but I want it to be a little extra, okay? So we're going to create something called Ultimate Tic-Tac-Toe. It's a fun game that I played growing up, and it's definitely something. We're going to make that today. I'll explain the rules of how it works once we get there. But first, I'm going to go, I'm going to have to edit that out. Anyways, I'll give you the feedback at the end, the feedback form for your points. But let me go ahead and create a new file. So you guys, this is where you guys can begin to follow along, right? So we're going to create a file. You can literally name it whatever you want. It's not like Java. It's not specific. You don't need to do anything fancy or special, whatever. And we're going to go ahead and recreate that hello world together, right? Just to make sure that all of you can run Tkinter properly. And if anyone has issues, we can take a little break, work that out. But first thing we're going to do, we're going to import Tkinter as TK. Why am I importing it as TK? Because if I had to write out Tkinter dot at the start of every widget I make, my fingers would fall off. So we're going to use TK instead. That's something you can do with Python. And then we also are going to do this. We're going to do from Tkinter import TTK, right? Because again, we want TTK or we can. I'm going to go ahead and disable Copilot because this can be a distraction. All right. So what we're going to do is we are going to create our window, right? Does anyone remember how to create the window? Any brave souls? No? Okay. So we're going to hold on to it because we're going to want to keep a reference to the window again so we can put things into it. So we're going to say window equals tk dot tk. A little weird. And it's funny saying this over and over again because TK is the name of our new mascot. So it's kind of like cool. It's like they made one after him. We're going to do window dot. This is something you can do in a lot of code editors. If you look here, right, we have all of the different attributes that we can use on this. And there are so many. But if you were ever curious about like, oh, what can this do? You can go ahead and go dig around in there. But I will tell you that it's window.title. And then we're going to set that to whatever we want. So in this case, we want it to be hello world because we're trying to do a hello world program. And then window.geometry is another one that we can do. You see it auto-completes there. And that's going to take a string with two numbers separated by an X. So we're going to make this 300 by 200. Be whatever you want. You can do variable sizes on the window, like you can do the click and drag type of stuff, but that is a little more complex. You'd have to look at the docs for that. After that, we're going to want to create the label, right? And let's see. Anyone have any guesses on how to create the label? Does anyone remember? Okay. Sure. I'm going to call it the hello label.
Hello label. Equals tk.label, or other than uppercase L. Then you do inside the parentheses window, comma, text equals hello world.
Okay, awesome. So we've got that. I do want to say, though, we've got a TTK label. Just me being picky, and that would perfectly work. But if you're making larger scale projects, you want to tend to lean towards TTK, because when you start getting to like real complex stuff, TK is going to fly off the rails, right? So we're going to create that. And then we got two more things we need to do. Any guesses? What's up? We got a packet. So we're going to do hello label dot pack. And then there's one more thing. Oop. Anything else? Awesome. Because if you forget to do that, I've done that so many times. I did that at Shell last year, and it made me go crazy. And then with that being said, however you guys run your Python, sorry, open the interpreter. Let me get in here. All right. With that being said, we can go ahead and run test.py. And then it's so big, but it's because my tiling manager. There you go. Boom. And now we have a hello world. We just made a program. Can everyone go ahead and run that? Make sure that we've got Tkinter all set up. You just came, for anyone that just came in, it's fine. We'll keep going with it. But we're just making sure everyone has everything installed. Any issues? What's up? You don't have Python installed.
I have Python. I don't know,
What operating system are you on? On VS Code, you should be able to press the play button on the top right, and then it may ask you to select an interpreter. I believe Python 3 should be listed there somewhere. How's everyone looking? Good? Comfortable? All right. What's up? It's TTK, not TKK. There you go. All good.
No, it's like you go to the browser.
Yeah, python.org. All right, I'm going to move on because it seems like the general consensus is that we're good. If anyone's having trouble, bother the person next to you. They are obligated to help you. All right. I'm going to give it a minute. All right, I'm going to go ahead and move on now. I'm going to show you guys a little more on how to implement functionality using TK. I'll give it a minute. I'm going to go ahead and move on now. Thank you. All right. So obviously this doesn't really do much, right? We have no term of kind of like state or function or really anything that this program is going to do. How are we going to add kind of a little more to it? So here's where I'm going to go ahead and speed up just a smidge. But here's what we're going to do, right? We're going to create a button. And that button is going to change it from hello world to goodbye world. And we can click it all we want and watch the text change, right? We want that little level of interactivity. So the first thing that we're going to do in order to create that sort of functionality is I would always recommend start by putting the widgets on the screen. Don't think too much about, because at the very least, you're going to need the screen to look the way it needs to before you start implementing stuff. So I'm going to create the toggle button, right? We're going to do toggle button equals ttk.button. We're going to pack that onto the window. We're going to do text equals toggle. And then we're going to take the toggle button and we're going to pack it. So we've got this button on screen now. And if we go ahead and run it, we should see that that's the case, right? but we didn't tell this button what to do. As you can see, it gave it custom styles. We kind of have that nice little bevel, the indent, the button that says toggle, but it doesn't know what it's doing. So the way buttons work is that it actually has another input called command. And command is going to take a function. It is not going to take a function call, but it's going to take a function. And I'll tell you what that means in just a sec. So for example, let's say we had a function called test. We would pass it in like this, not like this. I want to make that distinction now because that's going to come up later when we start adding more advanced functionality, but we'll get there in just a sec, right? So we need this command. How are we going to make this command to toggle this on and off? So what we can do is this. We can create a function called toggle. And right now it's going to take in nothing, right? But I want you to keep that in mind. Right now, this function is not really taking in anything. And what we're going to do is in this toggle, first thing we're going to do is we're going to say current text. And we want the text that's in the label, right? So how are we going to do that? Well, TTK is pretty awesome where you can basically just take one of their widgets and index it like an array using a string to get the property, right? So it's kind of like a dictionary if anyone's ever done anything with that. But if we want to go here, the only issue with this is that you're not going to get any autocomplete when you're indexing it this way. There's lots of other ways that you can do it, like a .config method or this, that, and the other. But I'm a personal fan of this, right? And so what we can do now is we can go ahead and print our current text. And so here's another thing that's going to be really, really weird that maybe you guys aren't really used to, is that while this window is up, your little terminal in VS Code is actually going to be running forever and listening to you. So for console logs or print statements, sorry, I'm JavaScript brain at the moment, we can run this here. And notice when I click toggle, oh, wait, I didn't. So what's the issue here? Does anyone know? Yeah, I didn't pass in the command. So I'm going to go in here. We're going to do command equals, and I'm going to call this toggle. And obviously, we haven't had the toggle functionality just yet. All we're doing is extracting the text from the label. So I'll go ahead and run this again. As you can see here, it now says hello world in the terminal right here, which it takes it from the label, right? Another thing that we're going to want to do is if we run this again, notice how close these two are together. This is feeling a little cramped. So I'm going to want to change this. What I'm going to do is I'm going to go into the hello label. And I'm going to say padding equals, I believe it's a tuple for X and Y values. I actually can't tell. I may have to go check the docs on that. But if I run this, see, there you go. Right. Anyways, we're printing hello world here. We've successfully extracted the text from here. And so this isn't a read-only thing. We could actually do it backwards. We could say hello label text equals goodbye world. And so that being said, all we need to do is if current text equals hello world, right? So if the text is currently hello world, then we're just going to change it to the opposite. We're going to say hello label text equals goodbye world. Oh, not the open mouth. There you go. He's sad. And then else we could say that hello label text is just going to go back to hello world. And with that being said, let's go ahead and run this. Look at that. We've now added the first piece of functionality to our GUI app. And so this is pretty cool. I'm not going to lie, when I learned this, like after taking C a little into CS1, I thought this right here was the coolest thing I've done in CS so far, which is crazy to me because we learned some cool stuff in class, right? It's just the gratification of actually having a real product for the code you've been writing. So GUI frameworks are good for that. And it's a lot of good fun here, right? So boom, we now have a button that changes text. And so here's the sort of dilemma that we have here now, though. Notice that this hello world, this toggle, isn't actually taking anything, right? And that's a little concerning. So we need to kind of figure out, well, what happens if we're importing this function, right? What happens if we're getting it from another library? What if we need to pass something into that command? And so things get a little tricky here because as I said, you can't call the function. So like, let's say, for example, let's try this, right? Let's say we have incoming text as a variable. What if we just wanted to set our hello label to that text, right? So you guys kind of see the issue here. How are we going to make that work? How does this work if we can only pass in an actual reference to the function and not call it? We could go ahead and try, we could say goodbye world, right? This should be fine. What happens when we run it though, it looks like it works, right? It looks like something happened here, but here's what really happened. When the main loop was started, it actually ran this command, right? So it successfully went to this command, passed it in and went here. Let's try something a little different. So let's see, trying to think of a good example to show you here how this wouldn't work. But notice how I didn't click the button and it still changed the text. That should be reason enough for you to be concerned, right? I didn't click the button, but the command still went off. The text still changed. So what you actually want to do, it's a little weird, but it's something you're going to have to get used to in Tkinter. You're actually going to create a Lambda function. Now, what a Lambda function is it's sort of this weird half reference, half function beast that you really don't need to think about too much. Just know that if you want to pass in inputs into Tkinter, you're going to have to use a Lambda function. And then all you can do is this. There you go. And so it sounds a little weird, but it's something that you're going to have to do, right? So for example, let's say x equals goodbye world, right? And then we come back here, we run the Python code again. And then notice how it's not like that at the start. And then when I click it, never mind, I get an error. Or no, the Lambda function doesn't take any input, I'm pretty sure. There you go. So the whole reason we create a Lambda function is because we're not actually supposed to give input to our command. So what we do is we make a command that calls a command with input. It's so stupid, but it's just the way that the GUI is architected. There's nothing we can do about it, right? But this is just how we have to do it. So you create a Lambda function and then call it the way you want. And so then what we could also do is we could say toggle. We could do math. I forget how to generate a random number in Python. This is embarrassing. Import math, or no, import random, and then random dot randint. We'll do 1 through 100. Then I'll come back here. I'll cancel this. I'll come back. And look, it's different every single time we call the function. So this is how we kind of have that dynamic data passed into these commands here. This is very important to understand that you do need to use the Lambda function. This is what tripped me up with Tkinter for a long, long time. So just keep in mind that this is something that you need to do. You're going to need to wrap everything in a Lambda. Don't ask me why. I wish I could tell you, but I didn't make Tkinter. So here we go. Now we have some basic logic going here. What's up? So we could, right? We could still do the toggle function without taking inputs in, but notice how that can be bad practice in some cases. Yeah. What happens if you want a button to generate you an AI response, right? The AI function that you're calling needs to have the prompt in there. So how are we supposed to pass input in there? That was more of my example to show you, is that we need to wrap it in a Lambda in order to use incoming data as a variable, as like an input to a function. What's up?
Is a Lambda just like an anonymous function?
Basically, sort of. Yeah. So it's just the way TK works. I hope it doesn't confuse you too much. Any questions about the command? All right, awesome. With that being said, I think we're going to start diving into the fun stuff. We're going to start creating our crazy ultimate tic-tac-toe. Things are going to get a little more complex here. So if you get lost, the code is available, but I will try my best to go slow. I will try my best to answer questions and be concise with it, right? So I'm just going to completely demolish test.py. I'm getting rid of it. I don't need it anymore. We're starting from scratch, right? So when it comes to creating something with Tkinter, my go-to is to start by placing the widgets, or at least by understanding where the widgets should go. So actually, let me explain to you ultimate tic-tac-toe, because I realize some of you probably have no idea what I'm talking about. So normal tic-tac-toe, right? You guys kind of know how tic-tac-toe works. You have a kind of like a 3x3 grid of squares, and then depending on your win state is getting 3 in a row. Well, what ultimate tic-tac-toe is it is a 3x3 of those boards. with one added mechanic that is what makes it a really fun brain game, in my opinion, right? So we've got these kind of grids set up here. So here's the way that it goes. On move 1, anyone can go, right? Whoever wants to go, or X typically, right? So this doesn't really matter too much, but let's say X places on this row right here, right? What that is going to do is whatever grid in your game, in the local tile you picked, whatever one you picked is what board is in play next. So that means now O has to make a move on this board because we did the middle left. And then if O wants to place it top right, then that means X is in game up here. Follow along, right? Does that sort of make sense? It is a very complex game, but algorithmically speaking, we can break it down, we can make it work. And it's a lot of fun because you can play some crazy mind games. Like there's no skill ceiling on Tic-Tac-Toe. Ultimate Tic-Tac-Toe things can get crazy. The only other thing that we need to consider is what happens if, for example, and obviously the ultimate goal is to get Tic-Tac-Toe with the Tic-Tac-Toes. When you win a board, you claim the whole board. And so your goal is to get Tic-Tac-Toe among the winning boards. It lasts a long time, but I tell you, it's a lot of fun. Okay, so we're going to make that work. Another thing, what's up?
What does a tie do on the
That's a really good question. I didn't think I thought about that when I did it. I'm pretty sure you just can't move there anymore. I think the way I set it up, I'm pretty sure you just can't make any active plays in there, and it kind of counts as like a dead square, like a neutral square.
So if you have a tie one and you make a move in a different board, that sends it to that.
So for the way it works is if a board is out of play and someone moves you there, you now are unbound and you can place any open board. So that logic would apply. I'm pretty sure what I did was if the board is full, don't move there. And that means it's fine for ties. It's just a dead board. Yeah. With that being said, any questions about like the overarching logic of Ultimate Tic-Tac-Toe? No. Okay. What about widgets? What are some, so I kind of just drew the board right here, kind of perfect. I'm going to keep using this. Is there anything else that we want on the screen? Well, one thing that might be really useful is to know whose turn it is. So we might want to have some sort of label kind of up here. Dang, this is so small. we might want to have a label up here, kind of talking about the game state, right? What's something else that we might want?
Board you're on?
Perfect. So we might want to highlight what the current board in play is. Maybe we could also even include that up here. So we could say at 1-1, right? But we could do both. And I do plan on doing both. Anything else that we might want on the screen? Kind of go ahead and symbolize my highlighting up here. 1-1. Anything else? The score we can use here as well. I didn't keep a tally of like winning score. It's just whenever you do, you kind of start over, right? Trying to think of anything else. We can go ahead and look at the example that I made here. So yeah, we have our little title up here. We have our board. So we have another kind of problem to consider is, again, we have the pack method, right? The pack that places things on top of each other. We only have pack left, pack right, but there's a little more complexity to it. So what I'm going to introduce, and I'm going to show you when we start getting to the coding, I'm going to explain it now though, is something called a frame. What a frame is it is a widget that has zero purpose. It is just a space to occupy. Why is that really important? Because that now gives us something else to put in as our anchor input when we create those widgets. But that being said, each of these right here is a frame. Oh, this is a frame. So we're going to create a bunch of frames, pack them. We're also going to use something called the grid. It creates a grid, right? You would say put it on row 1, row 2, row 3, whatever. And so really what this is a grid of frames in a 3x3 where each frame is a grid of buttons. Because again, we kind of want to be able to click on these, right? We want to be able to say, hey, I want to put my move there. So that's kind of the general consensus of what we actually have to put on the board in terms of widgets. So like I said, I personally like to work on the UI first and kind of add the implementation later. Only in Tkinter, I'm kind of backwards with like web and stuff, but it's just my personal preference. So that's what we're going to do because I'm the one running the workshop. So any questions before I get going? All right. I'm going to try my best not to take off too hard here, but we're going to move a little bit quicker than I've done with my devos. So we're going to import Tkinter as TK. And then from Tkinter, I imported it as Tkinter. From Tkinter, import TTK. I'm going to go ahead and sit down right now. If you guys have a question, holler, because I probably won't see you. Right. And then what we're going to do is we are going to, again, create our board object. We're going to create all of our widgets, stuff like that. So we're going to create the main window. We're going to do window equals tk.tk. We're going to set our Windows title to ultimate tic-tac-toe, right? And then we're also going to want to set our geometry. We can go ahead and set our geometry to a nice little square here, just because a tic-tac-toe game is relatively square. That's our main window. So we're going to kind of want that main sort of title at the top, and that's going to be a label. So we're going to say create title label. We're going to say title label equals ttk.label. And we're going to, again, put this on the window. And we're going to say our text is the Night Hacks Tkinter Workshop. Just to plug real quick, right? Another thing that we can do with labels and text, notice here if I type F, we got font. So I'm going to go ahead and show you just some general styles that you can do. So we can use Calibri, whatever you call it, 18. You can also go ahead and bold it, right? And again, all of these things are things that are available in the documentation. I would recommend reading it. And then we're going to pack the label. And you can also additionally put the padding in the pack method. I'm going to do that here. So I don't want everything to be clumped together. So I'm going to add padding of Y and padding of X to 20. So now this label kind of has some space around it so that not everything's all up in its space, right? And then we're also going to get our quick little description label. But again, these are all aesthetics and completely optional. You don't even need the label here, but we're going to say we're going to pack it on the window. And then we're going to say a 3x3 game of tic-tac-toe. And again, we're going to want to go ahead and use the font here. And then 18. And then I'm not going to bold this one. I'm also going to go ahead and minimize this for now because we don't need it right now. And then again, we're going to pack the label. That's something that you're going to get in the habit of doing. And another thing that I like to do all the way at the start of my program, so I do not forget, run the main loop. And we're going to do window.mainLoop. Call that as a function. So we have kind of our very bare minimum, but again, just to make sure that it works, we do have our, see, so here we go, right? What did I forget to do? I forgot to specify the parameter. I didn't put text equals. So that's something that you're going to have to do. And then here we go. So we now have our little tic-tac-toe thing here. Pretty neat. We have a window. And so, again, now we're kind of in the thing of like, we need to start placing these buttons on the board in this fancy 3x3x3 kind of manner. And so first thing we're going to do is we're going to kind of have, we also need that label, the turn label. I'm going to add that as well. Remember how we said we wanted to have something that says whose turn is what? So we're going to say turn label, again, equals ttk.label, window, and then we're going to make the text equal to X's turn because that is what it's always going to be at the start, right? X always goes first. And then we're also going to say similar font. I'm actually just going to go ahead and copy this to save me some time. And then boom. We also need to go ahead and pack that. Turn label dot pack. And we're also going to want some more padding here, just because we don't want everything all up on top of each other, right? And so there you go. We now have all of this packed up here. We got our label going. And now I'm going to start introducing you to styles. The reason I want to start doing that now is just because actually, I'll do it as it comes up, as we need it. We can go ahead and leave this here for now. What we're going to do is this. We now need to create our buttons, right? And so that's a lot of buttons. Like that's a lot of buttons. And I will be damned if I put if I have to do that many buttons. So what we're going to do is we're just going to go ahead and kind of use a loop here. What we're going to want to do is we're going to want to have a 3D array to sort of represent our buttons. So list comprehensions are awesome. Here's what we're going to do. It's going to look really funky because it's Python. But basically what we're going to do is we're going to use some shortcuts in Python to make a 3 by 3 by 3 array that is fully empty. It's called list comprehensions, right? So we're going to say empty array for nothing in range 3. So this creates our first array, right? Then we're going to wrap this in another array. Right? So now this is an array of empty arrays, okay? You've got that here. And then I'm pretty sure what we're going to do is we're going to do for underscore in range 3, and then wrap it again. And then this goes over here. And then we're going to do that one more time for underscore in range 3. And we're going to close it, and we're going to wrap it. So that's going to successfully create our empty 3 by 3 by 3 array. If you guys want to look at it a simpler way, you can do 4 open brackets, 1 closed, 4 underscore in range, 4 underscore in range, 4 underscore in range, right? Pretty simple pattern here. So looks complicated, but really all that is initializing our array, right? You can consider it just making a big empty 3 by 3 by 3. So we're going to initialize our buttons. And then what we're going to do is we're actually going to iterate through them. However, this is going to take a few loops, and that's perfectly fine. But keep in mind that we're going to need to keep track of a few different things. We're going to want the I and J index as we're iterating through 2 different things. We're going to want the I and J index of each board. Which board are we at, right? The big board, which I. And then once we are in that board, we're going to loop again, and we're going to want to know which I and J are we packing in the subboard. So there's going to be lots of loops. What I'm going to do is I'm going to call it board I. So BI in range 3. And then again, for board J in range 3. So now we are in the subboard, right? We've now, this part of the loop, we are now in the subboard. What we're going to do is we're going to create a frame. I'm going to call it the mini frame. And again, frames are nothing. They are just there so that you can use sort of packing and different types of layout geometries. So it really doesn't do anything. What we're going to do is we're going to create a ttk.frame, and we're going to mount that. I don't believe I actually set up a frame for the board. So I'm actually going to back up and do that really quickly. We're going to put the board in its own frame just so that everything's all nice put together. So we're just going to create our first frame, board frame equals ttk.frame, and we're going to mount our board to the screen. Padding, this does X and Y. Notice how sometimes I do pad X and pad Y. It's the same thing as doing padding just once, and it does it for both. And then again, we're going to do board underscore frame.pack. And there you go. We've got that there. So now that we've created the board frame, we actually want to place our little mini frames on the board. So what do you think the first input parameter is going to be to this function?
Board frame.
Board frame. That's our anchor. That's where we're placing it, right? And then with that being said, that's there. And then what we're going to do is we're going to say mini frame dot what? Okay, trick question. We don't want to use pack, because if we use pack, all of our boards are just going to be on top of each other. So this is where we're going to introduce a new layout. It's going to be called grid. And so what grid's going to do is going to keep track. Once you use it on a parent, that parent is now a grid parent. So for example, that's why we're not doing this on window. That's why we're doing it on board frame. Because if we did grid pack on the window, the whole thing, everything after would also have to be grid. So once you make that parent a certain geometry, it's stuck to that geometry, right? So keep that in mind. That's something important. So grid is going to take your row. And in this case, our row is going to be what? It's going to be board I. And our column is going to be board J. And so there you go. We've now sort of placed our mini board onto our big board. And we're going to say padding equals 10. Again, because we kind of want that space between our boards. We don't want them to be crammed up against each other, right? And there you go. So now we have created our little subboards. And again, we're going to do a double loop. We're going to say I. And now we're actually inside of those small boards, right? So we're doing I and J. And now we are actually on, oh, I forgot to say in, whoops, individual tiles. And I keep these little comments here to keep track of where we are in the code. It does help for sure. I don't know why I'm getting an error here. Did I spell range wrong? Invalid syntax. Whoa. My language server is probably just messed up. I'm probably just going to type it again. For J in range 3. See, there you go. Beauty of programming. And then we're going to just create our button, right? Create the button. So we're going to say button equals ttk.button. We're going to put that on the mini frame. And then we're going to make its text. We're going to use the text on the button as our signifier of whether it's taken by X or O, right? Obviously, this button is going to need a lot more because, again, this is the functionality part. We need a command to feed this button. But I'm not going to worry about that right now. We're kind of just going to make everything packed together. And then we're going to start conceptualizing how we're going to approach that. So we create the button. And then we're going to do button.what? Any takers? Grid. Perfect. And our row is going to be BI or I? I. And then our column is going to be J. And there you go. We now have all of our buttons. What we're also going to want to do is keep in mind that we have this button array at the top for a reason. This is going to be kind of like our entryway into all of these buttons, right? That's why we make an array to keep track of things. So at the very, very end, we're going to go buttons.append. Or no, we're going to do buttons at board I, board J, right? And then we're going to go board I dot append. Why are we only indexing 3 times and not to J? Well, because indexing it at I is going to give you that last row, like the lowest level. And then we're just appending onto it, right? So that's how you add the buttons to your array. Any questions so far? I know we kind of did a lot. Is anyone behind? Anyone lost? Okay. So with that being said, we can go ahead and run this and kind of take a look at what we're looking at. Whoa. Let's see. That option, padding. Oh, I believe I can only do pad X and pad Y here in the grid one. Yeah, you can only do that in... So this type of padding is only when you're instantiating the thing, not when you're using row. So I believe, yeah, see I did it here. And then I believe if I run it, there you go. So this looks a little weird, right? We're going to need to add some stylings later because we have a bunch of rectangles. And this obviously doesn't look great. Not to mention, clicking them does nothing, like actually nothing. So now is when we're going to get into the real nasty part, is we need to start thinking about how are we actually going to create a single function? Because again, you can't feed a button 2 functions. How are we going to create a single function that does all of this for us? So what we're going to do is we're going to come back up to the top because you kind of want to have all your logic at the top. It's kind of just best practice, right? So we're going to start thinking ultimate tic-tac-toe logic, right? And so what we're going to do is first and foremost, we are going to need another sort of array to represent our board. We already do have that one array, but that isn't meant to be our X's and O's. That is just references to our buttons in case we need to do anything with our actual widgets, right? So we're going to create a new one. And just for ease of use, I'm going to create a super board, which is just going to be a 3x3. Because what we're going to do is when we end up doing if you won or not, you're going to say if board, if like, you know how normal tic-tac-toe logic goes. If top left, middle, bottom, you win. And you just go through all the different possibilities. What we're going to do is we're going to create a super board that is just 3x3 with all of the big boards in them. Because what we can do is once we like claim a board, we'll just change everything to an X. And then we can just do the same function with our super board. Because a board full of X here, I see some confused faces, right? So when we're looking here, when we do tic-tac-toe, we're looking, are these 3 equal, right? So what is the question of equality, right? It's either X's or O's. But when we win, what we're going to do is, let's say we claim this board. We're going to make every single board, we're going to update it so that it's like taken. Notice how we overrode it and everything's O's. If we have 2 boards, and these are represented by arrays, if we run equals equals on these 2 boards with the same contents, it will come back true. So to save us that extra layer of having to go through every single, like a 4 times loop, what we can do is we can just have a super board that holds on to each of these, kind of just generally, and we can use equal equal there. So we're going to do super board This is going to be an array, and you're going to get used to this. We're going to do lots of array instantiations like this. In range 3. And the underline just means we don't really care about it, right? We're going to say the row, and then we're going to do 4 underscore in range 3. We're going to do row dot append. It's going to be empty for now. And then we're going to do superboard dot append the row. And so now we've created kind of like our superboard, which sounds so funny every time I say it. And what we're going to do is now we need to create the mini boards. And the mini boards is going to be that really deep array, right? So we're going to do mini board. We're going to do an array. And we're basically going to do this exact same thing 4 times. So we're going to do 4 underscore in range 3. We're going to grab the board. 4 underscore in range 3. So we're at the board now. After the board, we're going to have the mini board within it. And then we're going to go 4 underscore in range 3. We're going to create the row. And then 4 underscore in range 3. We're going to row dot append empty. And so this is basically just creating our empty thing, right? And then we're going to go mini board dot append row. And then board dot append mini board. And then mini boards dot append row, right? Or dot append mini board. Dot append board. Does everyone follow? Because this is just a bunch of like, we're just creating the data structure we're going to use. We have lots of nested loops. We have lots of nested arrays. But does anyone kind of have like a general understanding of what we're doing here? Awesome. Very deep array, 4D or 3D, 4D. I don't know. I'm not going to think on it too hard. And then from there, we're also going to want a few variables just to kind of keep track of things, right? So a big one's going to be whose turn is it? And so we can keep track of that with a bool. We could say x turn true. And we're going to instantiate that as true because, again, x always goes first. We're going to say the next board. What is this going to be? This is going to be the coordinates of the board that's in play, right? Because we will want to keep track of that. And so we're just going to make that as none for now, which is a nullish value in Python, because no board's in play right now. You can play at whatever board you want. And having none is useful for the example we talked about earlier. When someone sends you to a board that's already been taken, we just set next board to none, right? Straightforward. After that, we also need to keep track of the game's over. And so again, we're going to kind of instantiate that as false. Makes sense. First thing we're going to do is we're going to have a function to check winner. And this is going to be a pretty straightforward one, right? This one should be you should be able to genuinely reason this. But what you're going to do is you're just going to check all of the different possibilities on the board, which sounds complicated, but there really aren't that many. So what we're going to do is we're going to check for each row, column here. So we're going to do for I in range 3. And we're going to say we're checking both. So all of the columns and all of the rows are pretty simple. The only ones we need to hard code are the diagonals, but there's only 2 of them, so it's not that hard. So we're going to say if board of I of 0 equals board of I of 1 equals board of I of 2 does not equal empty, right? So if all of our things are equal and are not empty, because if we let empty be a condition for tic-tac-toe, there would instantly be a winner because all of the boards are empty right now. So we'd be hitting win condition all the time. So we just want to make sure that it's not empty either. And we're going to say return board I of 0. And you really could pick any of these to return. I just picked this one because it's simpler. But what we're doing is the check winner function will ultimately return who the winner is. So if it's X in that spot, in that string, then we're going to have an X be returned here, right? And then we're also going to say if board, and now we're just going to backwards. Board 0 of I equals board 1 of I equals board 2 of I does not equal empty string. Oh. And then we're just going to do the same thing. Return board 0 of I. So now we have the row and column, and now we just need to check for diagonal. And that's going to be just a bunch of hard coding, right? We're going to do 2 of them. So if board 0, 0 equals board 1 of 1 equals board 2 of 2 does not equal empty string, then we're just going to return board 0, 0. And then the other diagonal, if board 0, 2 equals board 1, 1 equals board 2, 2 of 0. We're again, does not equal empty string. Everything would have blown up if I didn't do that. We're going to do return board 0 of 2. And then last but not least, we have the condition of ties, right? So how are we going to check ties? All we're going to do is we're going to check. So at this point, this means we've checked every tile. So a really clever way that we can do at the very, very bottom of this is we can just go if we're going to use a function called all, which is going to give us an object that we can go through. It has all of the things in the array. So if all board I and j does not equal empty. So if every board slot is taken for I in range 3, for j in range 3. So it sounds a little complicated, but what we're saying is for all I and j's that we iterate through in those 2 loops, if they don't equal empty. So at this point, after these ifs, if there was a winner, we would have found it. So now all we're doing is, okay, we don't have a winner, but is every slot taken already? Is all of them not empty? And if that's the case, then we're just going to return a string that's tie because we have a tie. And then just at the very, very bottom, just good practice. Technically, there is no outcome where this will ever be needed, but just so things don't break, I just return nothing, right? So that's our check winner function. And then what we're going to do is we're just going to have a helper function for us. It's going to be check super winner. And all that's going to do, check super winner. Winner equals check winner of the super board. So remember, that's kind of what I was talking about. Now we kind of have an easier way to keep track of this also to distinguish so that we don't need like 2 different functions to check the big winner and to check the small winner. We have one, and again, if once you win the board, it will be absorbed into your character, and then we can just do equality checks like we've been doing up here. Because with the big board, board I of 1 would be an entire board array, and so would board I of 2. But you can still do that equality in Python, right? It works. I know that's something that C might like flip out over, but that's something we can do. And so now the really, 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 really fun part, which is actually the command to make the moves, right? That's gonna be a little tough, but we're gonna get through it. So here, function to handle the moves. I'm gonna call this the command function. I'm gonna bold this because this is gonna be a very important function because this is what we pass into our buttons. So I'm gonna call it make move. And what do we need to take in here? What do you guys think is something that we need to take in here? Okay, so we're gonna need to know, well, not really. This is gonna be a global variable, the extern. We need something a little more local to the window. We're gonna need our board index, which board we're on, right? Because remember where we called it down here? We have all of the buttons in an array, right? So we're gonna need the board I and board j. We're also gonna need the I and the j for the actual board that we're moving on. I'm gonna never say the word board ever again. We're also gonna need all of our buttons. Keep in mind that when we remember before in the hello world, we took the object and we indexed it by text. In order to do that, we are gonna need to have access to all of those buttons. And with that being said, we do also need the turn label in order to update it, right? We're gonna want the turn label to change based on whose turn it is. And with that being said, that is all the wonderful variables of our function. What's up?
Are buttons and turn label not global as well?
I can make, yeah, probably. I just wanted to, really at the end of the day, you don't want to use the globals. I got lazy at this point and stopped making them local references, but it's good practice to the reason it's good practice to do this is because what happens if the function is being created by another package you're using?
Oh, yes.
Those are always going to need inputs. There's nothing you can do to get around that to pass it to them. So it's really good practice to get used to using the Lambda functions, because for a lot of people, it's like this black magic they never want to touch. I'm kind of forcing you to get comfortable with it. At the end of the day, yes, I could have made all of these 6 global variables, but I kind of just wanted to simulate us doing what's right. I know not all the time we do what's right. We do what's easy, but it's fine. Just, you kind of get the point, right? And then again, next thing we're going to do is we're going to access the global variables, which is kind of ironic, but I did get lazy at the end, right? So now this is just us being able to get the global variables that are up here outside of the function. And that being said, we have now all of the things that we need to do. And so what we're going to do, first thing we want to do is we're going to want to say if next board, so like if, or here, let's not worry about the next board logic too much. Let's kind of just worry about like what we're trying to do here. The first thing we're going to want to do is we're actually going to want to grab the button we're concerned with. So how are we going to do that? Well, we're just going to index by bi, bj, I, and j. And this is just actually going to grab us the button. The reason we want the button, does anyone have an idea? We're going to need to update the text. When you click on the button, you're making your turn there. And so we're going to want to make the text that. So we're going to do just that. So button of text equals x if x turn, else O. Good old fancy ternary here, right? So now if it's x turn, we're going to get an x. If it's not, we're going to get a 0. Another thing that we're going to want to do is you actually, believe it or not, can't make a turn if someone's already made a turn on that square. So we're going to take state and we're going to set it equal to disabled. This is something else you can do in Tkinter. It's going to completely shut off that widget. So for a text entry field, disabling it won't let you type. Buttons won't let you click. Drop downs won't drop, right? So you can use this disabled state. And then what we're going to do is we're also going to set our mini board of I and j to be x as well. So x if x turn, else 0. Because what we did up here is we actually changed the text displayed on it, but we didn't keep track in our big array of the current state of the game. So we're just updating all of that. We're updating all of the state. At which point, let's go ahead and run it here. Let's actually see if we get any errors. Oh, you want to know why? We're not actually calling it. So I'm going to go ahead and update this now. Now that we have this, right? Can anyone tell me what they think it's going to be? Command equals what? Lambda. And that's going to be make move of bi, bj, I, j, buttons, and what was the last one? Turn label. Turn label. There you go. And so now if we run this, hopefully I don't get any errors. Okay, let's find out what the issue is here. So we've got make move. Just to make sure that make move is actually getting all of its variables, we can go ahead and print bi, bj, I, j, buttons, and turn label. Let's go ahead and run this again. So we're successfully getting the stuff here, as you can see. It's quite a mess, but we are getting it. So then what's going on here? Are we getting the right button? Ooh. Okay, well, we're getting the right button. Notice how all of the buttons are, oh, maybe not. Let's print bi, bj, I, and j. Okay, for some reason, they're all set to 2, 2, 2, 2, 2, which means we're probably making an issue with the function call here. So another thing that we might have to do for certain lambdas is pass in the parameters like this. Something I forgot to explain. So lambdas do take function arguments as well. In order to have the, like your call after the colon have these access to these, you're going to need to pass them in. Okay, so let's go ahead and run this. Okay, there you go. So look, we've now got kind of tic-tac-toe kind of going on here, right? Notice how the turn doesn't seem to be changing. We didn't remember to update that, but we can click and it's actually setting it. And look, if I click this button again, we're not getting any sort of feedback here. So this is sort of in the right direction. Something we do need to do before we forget is we're going to set x turn equals, able to do that? No. Equals true if x turn else false. Did that backwards. So if x turn is true, we're setting it to false. And then with that being said, we should be able to run this and then it should alternate. There you go. Look, we now have alternating logic between our tic-tac-toes. Great. And now we actually need to start worrying about the real logic that's going to happen with all of this going on here. So we're going to start needing to think about like our next board, right? So we can actually go ahead and update the board. We're going to say next board equals I and j. For the next board, we're actually going to use a tuple, which is just an array, an immutable array for the I and the j. And then we're going to say, we're only going to set it there if superboard of I and j equals empty. What is this for? Remember, if we have a board that's already been claimed that isn't empty, we don't actually want to set our next board there because there's nothing that we could do. And then I'm actually going to bring this down here, and I very easily could have put x turn equals not x turn. I'm going to do that just for clarity. And then now we kind of have the next board. So we need to keep track of like, are they allowed to even move there, right? So we're going to put that up at the top. Because what we want to do is we want to back out early. So check if they are in the right board. So we're going to say if next board. And so if there is a next board, right, we first need to consider, because remember, we have the opportunity where it can be none. So basically this is saying if we have a next board that is not none and next board does not equal board I, board j. So we're saying, hey, if the button we're currently clicking does not equal the next board and a next board exists, we're just going to head and returning, right? We're not going to do anything at all. We're just going to back out early. And so here we go. I clicked bottom right. I don't have the highlighting set up yet, but look, I'm clicking all over here and it's not making anything. But if I click bottom right, oh, now I can go up here. I click there, I kind of expand a little. I can go over here, nothing, nothing, bam. And then I go over here. Nope, we're in play over here. So look, we kind of have that general sort of bouncing around of things, but obviously without the highlighting, that is very hard to see. But at least we know that we have that sort of logic going now. What's up?
Can you explain why we put if next board in that if statement? Why don't we just have next board doesn't equal the other?
So basically, I mean, I guess we could have none and we could miss that next board, but we're trying to avoid accessing, we're avoiding trying to do a none equality. That's just bad practice in most cases. But
does that give an error or you just don't want to do that?
It's something you don't really want to do. It may or may not throw an error. We can see. Basically, the reason we're doing it is we're making sure that there is a next board to begin with. But I believe, so yeah, see, look, our next board is currently none. Because remember, we instantiated with none. You can't do an equality operation on none.
Okay.
It doesn't do anything. So we need to make sure that next board is being like it exists. So if next board doesn't exist, then we're not going to do any backing out. All right. Now we kind of also want to think about like, we're going to pull out the little mini boards here. Hold on. So we're going to want to extract our mini board. So we're going to say mini board equals mini boards of BI and BJ, right? Because we want to have access to our current mini board. And then if mini board I j does not equal empty, return. What is this doing? Anyone have an idea? I know it's a little complex. We have all the nested boards. So what this is doing, what's up?
It's saying if there's already something in that.
Perfect. So this is how we're making sure, but we can probably get rid of this logic since we already disabled the button. This is just, another example of what we kind of some things that we want to like look out for. Now we kind of have two different ways that we can go here. We can start thinking about handling our winners, or we can start working on getting our style set up. What do you guys want to do? Do you want to start having the highlights, or do you want to start working on making the winners work? Making the winners work? Okay. So what we're going to do is we already have that winner function. So after we've kind of like stopped all of our cases up here where we want to like tell them to leave us alone, we're going to say winner equals check winner. And do you think we're going to do that with the mini board first? And what we're going to do is if we have a winner, when we win a small board, we want to completely absolve it. If X wins top left board, it eats the whole thing. So what we're going to do is we're going to iterate through all of the buttons in there. So for button in row, and we're going to set all of our buttons to disabled, because this means we won our little small board. And then we're going to set our super board equal to the winner. So this is how we're keeping track of like the big boards, keeping track and also disabling all of the buttons. And then what we're going to do is we're going to say if the winner does not equal tie, right? We don't want to do this always, but what we're going to do is we're going to basically, even if like, for example, we had O, X, O, and then we have Tic-Tac-Toe, we're just going to take every single square and fill it with the winner. Only if it's not a tie. You don't want to see the word tie 9 times on a screen. That's kind of weird. But in the case of not a tie, we're just going to do the same thing again. For row in buttons, BI, BJ, and then for button in row, and we're just going to say B text equals winner. And then we're going to go ahead and create a style later on to make sure that that's kind of all working properly. So set winner. Yeah. Yeah. So in Python, the way that works is you can actually, it's kind of weird, but empty strings count as falsy. That means that if we have a winner, that's why here, right? If we somehow had some sort of case where none of this happens, which I think is impossible, but if it's nothing, we're just checking to make sure, right? So if we have a winner that isn't empty string, or no, this is if it's not a winner and if it's not a tie, we'll just empty string it. So if we have a winner at all, if it's a tie, X or O, we just want to check first. And so again, empty string is going to be falsy. It's like a 0 in C, right?
What does super board equals winner do?
So basically, we're keeping another like array that looks like this board that is just it's basically representing each board who won it. Why do we want to do that? It's so that we can use this same check winner function on the big board. Because if not, we'd have to write a whole separate function, right? So we're just kind of making it easy on ourselves by doing that.
Wouldn't we have to index
Yeah.
Superboard?
Oh, totally. We would have to index by BIBJ. Good catch. And so it's really hard to win this, even if you have a cooperating partner, but we're bottom right. I'm going to send it back here. We're here. And then I'm going to send it back there. Did we win that, though? This should have successfully gone over everything here, right? I'm going to try to win again. I just want to make sure that we want, because we did the logic here for all of the text. So if the winner does not equal tie, we went through all of the, where, oh, that's probably what it is right here.
Yeah.
Awesome. Good catch. Thank you. That is probably, it's been a long day, but anyways, bottom right, we'll go here, here.
I'm getting an error at 65.
I'm getting the same thing.
65?
Yeah, it says J and mini board is out of index for me.
You said where at?
I think yours is 71.
71. If mini boards I and J does so mini board is we grab that from mini boards at BI BJ. If mini board I and J does not equal nothing, return. You said you're getting an out of bounds?
Yeah, that's the next out of range.
Go up here and make sure that you're declaring it's coming from mini boards. Make sure, how many loops do you have in here?
I might have just typed something.
It's probably all the B and I and all the indexing. It gets kind of out of hand. You could also try printing mini board and seeing how many times the arrays are nested. That'll tell you your I and J range. Any luck? I might have to keep going.
Yeah, you're good. You can continue.
Yeah. All right. So I'm gonna go ahead and I forget what board I'm on right now. There you go. Now I'm on bottom right. We go here, go there, go up. Still didn't take everything. Anyone fact check me here? I'm trying to figure out why this isn't working. I have lots of sets of eyes in here. So we're first grabbing our winner. Actually gonna go ahead and print the mini board as well. Okay.
Do you mind scrolling up to the four?
Yeah,
for a second?
this one or
That's my problem. Is that my mini board is a 1x3 array, so it's one dimensional. It has 3 elements. So I've just probably just typed something.
yeah. So it's printing winner. Winter's coming back is.
I don't think you're updating the board before printing the winner.
These are my problems.
Am I forgetting to update the actual? Oh, I might be. I think I'm forgetting to update the.
Yeah, I think you're updating the winner.
I have to check that after, right? Oh yeah. Okay. No, thank you. That's good. All right, now everything should work. Good catch. All right, I'm gonna try that again one more time. We got O here. Bring it right. Bring it back. Oh shit. Over here. There you go. All right. Sorry about that. We now have the logic of absolving all of the mini boards. Question? I moved. So we were looking for the winner before we actually updated the board and made the move. So very Ricky mistake, but if you just move this code under that code, it'll work fine. So that being said, we now have that sort of logic down. Now, for the most part, we are actually pretty close to done. A lot of what we're going to be doing now is we're going to be setting styling for all of these different things, right? So what we're going to do, we already did the winner handling. We also want to handle our super winner, right? Because what happens when all of the boards line up in the way that you get a super winner, right? You have the rows lined up and everything like that. So what we're going to say is the super winner equals check super winner, which again is like sort of just an extra helper function for us. And so if we have a super winner, I said super whiner, whoopsies. What are we going to want to do if your move puts you in a winning spot?
If you're updating the board after
Where at?
you don't change the super board until like after what you're like putting right now.
Right. I'll just put all the updating logic at the top. I don't know why this is all right. I don't know why I'm getting it. Oh, because of this. All right. So I'm just gonna go ahead for the sake of this little workshop here. I'm just gonna clear the board, right? So for BI, for BJ, for I, for BJ or for J, button equals buttons of BI, BJ, I, J. We're gonna say button state equals enabled. We're gonna like reset everything, right? And then we're going to button text equals empty string. And then we're also gonna say that xturn equals true. And next board equals false. You could do a lot more with your win state once you actually win the entire game, but for the sake of this, I'm just gonna wipe everything and reset back to base. But we have the logic to absolve everything. So now really all that's left is gonna be styling, right? We need to have, we need to highlight, yeah?
Do you have to reset your like store?
Oh yeah, we would have to we would have to empty. I'm not going to do that because we're like getting low on time, but theoretically you would just completely demolish all of your arrays and do those for loops again on top of each other. So how are we going to handle the stylings, right? We're going to use the actual Tkinter style component, and that's going to be, we're going to kind of do it down here. We're going to create the styles here with the rest of the Tkinter stuff. And what we're going to do is we're going to create button styles, right? And what we're going to do is we're going to say button style equals TTK. And so style is kind of like an object in itself. It's not like pack where you append it onto things. You kind of create your own style object. And then you use the .configure method to update different things about it, right? So what we can do is we can actually create sort of like a style state as well, which is really helpful for certain things. So we can do our tic-tac-toe button, and we're going to say the font is, we're going to use the same font for most of these. We're going to say maybe size 14, and then we're also going to say bold, right? So now we kind of have the style for the actual buttons because we kind of want those X's to be a little bigger. They were small. Then what we can do is we can actually create another style called captured.tButton, which is sort of like a state, right? So we want to kind of change the button when it's captured. We may want to make it like look red or something like that. So what we're going to do is we're going to set bold. We're going to set 14. But what we're also going to do is we're going to add padding of 5, width of 4, height of 2, and foreground equal to red. So right now what's going to happen is when we set the captured T button style, it's going to grow a little and it's going to turn red. So that way you kind of have a good indication of what kind of buttons have been captured by like the whole, when we like do the whole board, when we capture the whole board. And then we are also going to do button style.map T button. We're going to say the foreground equals. So what we're doing is we're actually mapping, we're doing a conditional style. So what we're saying is if the button is disabled, we want it to be black, right? And then other than that, we're going to set our background. And then we're going to do not disabled. And then I have a custom hex code that I use when I wrote this demo up. I'm just going to put that in here, but you can put any color you want. With that being said, we now have these sort of like styles. We're also going to do button style. So we're going to create the style for the frames. We're going to do button style What's up? All right.
This is just a cool quick thing. If anyone wants to pay cash dues or wants to pay dues in cash right now, I am about to leave. So if you want to do that now, this will be the best time. Thank you. I will be here for all NIHEX meetings. So if you can't pay right now or want to go to different NIHEX meetings for cash, I will be there. Thank you.
All right, I'm just gonna go ahead and configure more of these styles. All of these are kind of just semantic reasons that we're picking this. We're gonna do background equals, and then again, another hex code that I have set up here. Right, so here's what we've got set up now. We have all of our styles going on here. And so now we come back up here to the top. When we make our move, we are gonna wanna like update our styles here. So
You mind going down to the styles?
yeah, go ahead, spend some time to copy there. I'll kind of explain it more conceptually. We should be done within the next 15, 20 minutes. I know I've been running this one long, but it seems like most of you guys have been following along, which is nice. All good? All right. So what we're going to want to do is if we have a winner, right, when we do that whole thing where we make the text equal to winner, we're also going to want to set the button style, right? And we're going to set that equal to, remember, we created a capture.tButton style. So we can just do that. And so now when we capture a section, it's going to get that style, right? Another thing we're going to do is when we get a super winner and we want to reset, we're going to set the button style back to the base T button, right? Because we want to kind of like undo all of that. And then the last thing that we really want to do is we're going to want a function to basically highlight the next board, right? And so I'm going to make that its own little separate function so that we can call it. But we're going to create highlight next board. Weird capitalization here. And this is just going to take in our buttons. And then we're going to do for BI in range 3, for BJ in range 3. Lots of 3 for loops here. And then we're going to get our frame equals buttons BI of BJ of 0 dot master. This is more Tic-Tac-Toe stuff. We're basically just grabbing the entirety of the frame. We're grabbing the frame that the button belongs to. So the dot master thing is something you can do on all widgets. Do you remember how I said that first input parameter is what you're anchoring it to? Tic-Tac-Toe's old, and in old code, they use master to describe a lot of things. So basically, this is just grabbing its parent frame. If we did this on the title label, it would be window. But this case is just giving us the frame that the button's in, right? And then from there, we're going to do if next board and next board equals BI of BJ. We're going to say frame.configure style equals active.tframe. So we're just saying, hey, if we have a next board, we're going to set the active frame style to that thing. If not, we're going to want to set it to tframe. So we're going to do again frame.configure style equals tframe. That being said, let's see if we can run this, see if it works. It's not highlighting properly. Am I still able? I'm not able to click anything that I'm not supposed to, right? We've got this here. So what else is going on here, right? We've got highlight board. We forgot to call the function. That's what happened. So at the very, very bottom, after we kind of handle all of the other different state things, we're just going to call highlight next board, and we're going to pass in the buttons. Let's try that again. So now I click. It's not doing anything there. Making sure everything's good here. Highlight next board, passing in the buttons. Let's see what we're missing. We've got B of I, B of J. We're successfully grabbing our frame using master. We're checking next board. We're setting up our frames here. Let's see. Go ahead and print the variables here, debugging practices. So it successfully knows that it's at 2, 0. Now we're at board 0, 2. It knows we're at this board, but it's not actually configuring the style unless I didn't create the active.tframe style. Oh, it's not active frame. It's active frame, not active tframe. No, apparently not. Am I doing that on the wrong board frame? I don't think. Oh, I'm not actually attaching the style yet. So we have board frame here, style equals tframe. Hopefully this is it, because it's getting late. I'm getting tired, making silly mistakes. No, nothing here. Set this to frame. I think we're using it properly. Frame of style. I'm not calling it an active.frame. Yeah, layout frame not found. So that's an issue here. Board frame style equals frame, but we have the frame style right here. I don't know where that's going wrong. You don't have to pack the styles. We're using a TTK style. I'm not entirely sure why, but in my last code, I called highlight next move right at the start. Maybe that does something. Well, this is our last feature. I hope that I don't have to let go without figuring this out, but I am going to try to figure this out. So we're looking here. It says that we don't have a style called frame, but we see right here that we did create a style properly. We did configure it using the style here. We do the style on mini frame, right? We're using a TTK frame here.
I can have button style like twice. We have the button styles, and then under the frame style thing, they're also titled button style.
Oh, that's a good question. It was like that on my sample project that I made. We could try doing frame style. Let's go for it. So we have frame style. And then we can go ahead here and do frame style equals ttk.style. Putting the T frame back in case that there is Tkinter reasoning for that. I kind of did have that and then removed it prematurely. And then maybe it's active.tframe.
Will this be posted on Discord?
Yeah, it'll be up. Okay, well, we have a different error now, which is always a good thing when you're making stuff. Layout active.frame. I acted active.frame. I updated it to T-frame. So I think you actually do need the T in front of the object that you're doing. That's probably Tkinter specific. It's still not properly applying the T-frame, which is a little confusing. Let's try a different background. So we're going to say where we apply active.tframe, we're going to print BIBJ, active frame. And then we'll try this again. So I can close this, open it, just making sure it detects the proper active frame. Active frame's at 2.0. That's fine. We're actually going to go to the style active.tframe. Let's change the background. Trying to think of a good hex code. Does anyone know the hex code for black? I forget. It's 0. Yeah, 0, 0. Yeah, it doesn't seem to be successfully applying the styles. The styles, as you can see, applied to the actual buttons and the frames, which is the confusing part.
Are the buttons fully filling their own frames?
Interesting. They might be.
Some padding.
Yeah, they might be fully in front of. Let's see. Let's go look at the buttons. Yeah, we could try that. I don't actually know if it'll allow me to do that type of padding. Let's find out. It might get mad at me. Interesting. No padding around the buttons. I don't know if something's wrong with my system right now, but none of the styles I seem to be adding are changing anything. I could try that again. Pad. No, it's only padding. It's the only thing that autocorrects. Let's see if there's anything in the initialization of my frame. So we're starting with the T frame, the mini frame. We have the padding X, padding Y. Do
buttons have a set size?
We changed them with the T button style.
You could try changing the frame background right at the start to see if it works at all.
We could try that. So we could try the board frame. Pretty sure red is an option. Okay, no backgrounds on this frame apparently. Is it BG? No, apparently there's no ability to do that without using a normal. Here, let's do T frame. We'll do also the background. Okay, so the frame, the actual big frame.
I think it is just the buttons covering it up.
Yeah, it probably is the buttons. You might be right. I think you are right, actually. If it's just the buttons covering it up, then I think if we go to T button, I think T button applies to all of our buttons at the start. What we can do is we could say pad X equals 5, pad Y equals 5.
Isn't padding internal to the button? Is there like margin?
Right.
Is there a way to make the buttons smaller?
We could probably, I think padding the buttons would put the space around it. I don't know if that would, here, button. I think you're right though. The styles are applying, it's just hidden. Where did I put that? Padding in the frame probably wouldn't work, would it? We could do padding 5. Maybe. There you go, padding in the frame. Okay, so now that took a while. I'm sorry for the trouble and sorry for holding you guys. But look, we have now, right, the ability to know what board we're on. What I also did in my demo is just a super quick function to update the X's and O's turn. Be honest with me, if you guys want to do that together, you guys have an idea because it's getting late. I don't want to hold you guys up for too long. No consensus, I'll do it. It'll be pretty quick. Should also just be a function that should just be def update turn label. And that's going to take in, just make sure I have this right. So we're going to take in the turn label and we're going to say if next board, then we're going to say turn label text. equals, and we're going to use a format string here. So we're going to say it's going to be x if x turn, else O. We're going to say it's their turn at next board. And so now the turn label is going to say not only whose turn it is, but that they have a position to go to. But we also want to keep track where in cases where there isn't a next turn. So we're basically just going to say this again, but minus the at. I don't know why this is giving me a text error. I have my closing bracket. X if X turn. Oh, I think it's because I'm using. Yeah. There you go. And then all we're just going to do is we're going to call update turn label at the very, very end with the turn label. There you go. Now we have O's turn at 2, 2, 0, 0, 2, 1. Oh, it seems like our X and Y coordinates are backwards. Whatever. Right. But look, and now look, when we claim that, I probably should have done it backwards. I should have gone bigger instead of went smaller, but that's just an issue with the way I configured my styles. But as you can see, we applied those styles successfully once you've claimed a whole board. I'm going to see if I can try my damnedest to get me a win here. I probably shouldn't be trying to win with O. In that case, I'm going to go here. It just went O twice. Okay, well, as you can see, there's a lot going on here. Let's try to go back up here, here, and then X. X's turn. We'll go here. O's turn. Send us back up. X turn. Okay. O. We're gonna throw top right, and then we're gonna go. We're gonna go here, and then O's gonna go up here. Oh no, O's winning. We got X turn here. It's gonna be really underwhelming if this doesn't work. Give X wherever he wants. Oh, okay. Well, I should have paused it until you clicked again. But as you can see, we did successfully wipe the board, which is what our winning logic was. A little underwhelming that it just takes it from you like that, and you don't get to sit in your satisfaction. But with that being said, like, it's my general mission. This is kind of what I wanted, right? We hit some bumps with styling and whatnot. Thank you for being patient with me. But with that being said, I think I'm about done. Any final questions before I get into some final touches?